Welcome to Cpp.chat, a sometimes weekly look at what's going on in the world of C++, chatting with guests from the community. We'll introduce those guests in just a moment. First of all, we need to hand over to John, who's going to read a disclaimer. John?
Thank you, Phil. The information in this episode is true and complete to the best of our knowledge. All recommendations are made without guarantee on the part of the speaker or Cpp.chat. The guests and hosts disclaim any liability in connection with the use of this information. All right, so we're ready to get started. We have two guests today who have not been on before. We're going to talk with Francis Buontempo and Andy Balaam, and I think we're going to start talking with Francis about the book. Those of you who are in the chat channel see the cover of the book, and it's called Genetic Algorithms and Machine Learning for Programmers, with the subtitle, Create AI Models and Evolve Solutions. Good day to both of you.
Hi.
Hello.
Do we want to do a roundup before we do this?
We should do it because
we
otherwise
just did the previous episode, so it hasn't changed much, I don't think. But
there were things we didn't get to.
Oh, okay. Should we start with those?
Yeah, I don't think you've mentioned before, have you, on the show that the call for submissions for C++ now is open?
Oh, I think I did, but if not, it's important for people to know because today is, we think we have exactly 10 days from the recording to get those in, so there's not much time left. In fact, in the last 10 days is when they all start coming in. So we have a handful now, but they're going to start coming in hot and heavy. So do get your submissions in if you want to be speaking and asking.
Yeah, we definitely didn't get to that meeting C++, the finally getting the videos online. We were expecting to start towards the end of last year, but they've been a little bit delayed. But the lightning talks are, as far as I know, all up now. And I think the keynotes as well, and should be getting into the talks. So by the time you hear this, if you're not listening live, some more of them should be out. So if you've been waiting for those, check them out. And some C++ on C news.
Excellent.
Now, only 3 weeks away. We've got all our volunteers selected, and the diversity program we mentioned last time is also closed. But students can still apply, at least at the time of this recording. So if you're a student, you can get in for £50 if you fill out a form. I'll put the details for that in the show notes. And I've also just recently published some info on travel and hotel information. So if you're planning a trip now, I'll post a link to that as well.
So you're less than a month away. You must be going crazy. This is the.
We're encountering a few unforeseen difficulties. But
yes,
we expected that.
I can only imagine getting the conference off the ground the first time, the cold sweats you're having when suddenly you think, what do we do about this? And, you know, something you hadn't thought about, and suddenly you realize there's not nearly enough time to do what you want.
Well, we remember to get some speakers.
That's probably important.
And a venue. So we're most of the way there.
Yeah. The rest of it's.
What could possibly go wrong?
Speaking of getting close, Adi just let us know that Core C++ submission deadline is in 2 days. So if you're wanting to speak at the Core C++, which is the new conference in Israel, and it's so this is just getting off the ground there. It's a new first-time conference. And if you're interested in that, go to the website and look at the details. But the deadline is 2 days. So you've got to get that submission in quick.
If you're listening to this in podcast form, then you're probably already too late. But what I will do is I'll try and put a link to this in the previous episode's show notes, which hopefully will go out in time.
Excellent. Oh, that's very good. So the other thing that we wanted to talk about, or perhaps wanted to talk about, was a bit of the IOTA kerfuffle. It's like, I guess what happened, it starts with Eric Niebler, who wrote this example code on Pythagorean triples. Pythagorean triples are sets of integers that follow the pattern where the squares of the two smaller equal the sum of the squares of the two smaller equal the square of the larger. And so there's a number of ways that you could calculate these and find these. I don't know that mathematicians have determined if this is a finite set or if there's some unbounded unknown number of these. But in any case, you can have the computer do all the hard crunching. And there's different ways you can code that. And he was showing how you could code that using ranges, because that's what he's trying to, encourage people to learn how to use ranges, which is great. And there's a blog post that was up. And what was the name of the blog post? The blog post was just modern C++ lamentations, where he's a game programmer, I think, who kind of picks this apart and says, this is insane. That's kind of a paraphrase. And one of the things that he's talking about is how difficult this process is going to be to debug, and how there's not enough thought into those kinds of things. And then one of the things that he goes off on as well is that one of the names for one of the range algorithms is iota. And he says, what a crazy, useless, non-intuitive, what a bad name. And so this has triggered responses. Ben wrote a response, and
thoughts on modern C++ and game dev.
Yes, and also Sean wrote a response. Sean Parent wrote a response. So both of them have written responses, but what one of the points that Sean made was he tracked back a little bit of the history of where the term iota comes from. Eric certainly did not make it up for the ranges library. The iota is an algorithm that's been in the standard since C++ 11, and what it does is given a specification of a range, and then you pass in a value. And what the algorithm is going to do is it's going to put the value that you put into the first item in the range, and then increment that value and populate the range with these increments. So it's just a very quick way of saying, I want to fill this range with 1 through n, or whatever the size of the range is. And it's very easy to do. I find it useful if you want to build an index. So let's suppose I wanted to create a container where the contents of the container are iterators into some other range or some other container. And so it's very easy with iota to pass in the begin value of a container, and then what you have is a set of iterators into the original container. Then you can sort those iterators or do whatever you want to do. Use that to splice the other container if it happens to be a list or whatever you want to do. It's just a very quick and easy way to make an index. And one of the things that Sean said was, he said, well, it is not something to be proud of that we don't know what iota means. It's somewhat of an embarrassment. And this was taken as iota shaming. If you don't know what this is, you should be embarrassed. That's not really what he meant. What he meant was that that it is a good thing to know the history of the terms we use, because the history of iota goes back to some of the early work done in computer science. So anyway, lovely little and fun articles to read to get caught up there.
The question is, did any of that make 1 iota a difference?
Well, I think that the name comes up, but I think there is a discussion. There is an interesting discussion about debuggability, and one of the points that Ben made was that debugging shouldn't be our first line of defense. We should actually be writing code that relies on types, and if your first thought when you have a problem is let's spend a lot of time in the debugger, that's kind of I guess if you saw Dan Sachs's keynote, one of the points he made is that there's kind of a difference in approach with C programmers, because he said that to a C programmer, what programming means is debugging. That's what it means. So you just write your code as quick as you possible, and you go into the debugger and make sure it does what you really want. And he's kind of implying that that's not really the most effective way to write code. Maybe we should give more thought to see if we can create the code so that it's going to execute correctly without having to be, step through every line of code.
Yeah, I agree with that.
Yeah, I think there's some interesting stuff in that.
It always depends on the domain, though, right? Some domains lend themselves to different ways of working, and And if the original, I haven't read any of these posts, but if the original post was saying my domain is being excluded by modern C++, I guess that's something that modern C++ should listen to at the very least. It may not be right, of course, but.
Yes, I think so. But I think also, I mean, there's a study group now for game developers. I think that the standards committee is listening to game developers. But I also think that sometimes the state of the art in a domain might be missing opportunities that others can say, look, this is what's going on in the world of languages. You're so focused on making games, and you make great games. There's nothing wrong with that. But there's a better approach that will, in the long run, do better for you. I'm not saying it's the case. I'm just saying that perhaps that situation can happen.
Yeah, and it would be great if this was a constructive conversation, and then everyone would benefit from that.
Yeah, but the way it goes. It's largely taking place on Twitter, so it probably can't be constructive. Anyway, read it and enjoy.
Put all of those posts in the show notes.
Yeah. So yeah, you can do that.
I'm sure most people have seen most of them already.
Speaking of reading, Francis, let's talk about your book.
Sure. Well, what do you want to know?
Well, first of all, what made you want to write a book? I mean, I assume you're not doing it for the money.
No, though I have sold a surprising number of copies and made a few quid or dollars or whatever so far.
Oh, great.
What ended up happening was I've given a few talks at particularly the ACCU conference ages ago. I interviewed a candidate for a job in a previous post, and the other guy came out and said they couldn't code their way out of a paper bag. And I thought, I don't think I can code my way out of a paper bag because I do not know what that means. So this got under my skin, and I came out with a variety of talks, several of them using techniques that might be slightly to do with machine learning, like genetic algorithms, slightly to do with some AI, maybe some cellular automaton and things like that. So I totally over-engineered this, and I did a series of talks about how to code your way out of a paper bag. Now, it turns out Code Your Way Out of a Paper Bag wasn't really a good title according to the publishers. What you need is some buzzwords in there. So that's why the title of my book is far too long, and I have to look it up to find out what it's really called.
I see.
So you'll find echoes on the internet of things I've written up for ACCU's Overload magazine, or some YouTube videos of previous ACCU conferences. So there's some diffusion in there which allows me to explore how Monte Carlo simulations work, which actually does crop up in some machine learning contexts. But basically, start with a paper bag and something in it and make it go out in a variety of different ways. So I was doing the talks to practice some machine learning and some maths because I love this kind of stuff. It's really fascinating. And at some point I thought I've probably actually got enough to write a book. Let's see what happens. And here we are. So slightly self-indulgent, frankly, but I think I can code my way out of a paper bag. I've even got a certificate to prove it. I got the first talk I gave at the ACCU conference. I got anyone who felt I'd done well enough to sign my certificate, and it's proudly on my bookcase in a completely different room. If I can find the chat channel, here we go. Wrong link. So yeah, I've just basically pulled together loads of topics I've been thinking about writing about, and there is my certificate wending its way to the chat on the Slack channel. Ta-da! How's that?
I have to say, this is classic Fran, that someone once said something that annoyed her, and that's turned
It didn't annoy me. It made me start thinking, and here we are, 10 years later, and what have I done? Over-engineered this guy as well. Why not?
Well, it's interesting that phrase, the phrase that actually that attracts me as the no-brainer thing to do. I mean, that's the idea, is, coding your way out of a paper. How hard can that be, right? That's the idea. What I've always heard is, or actually I always heard, but I heard it, and this stuck with me because I thought it was so funny. That someone wasn't smart enough to pour water out of a boot if the instructions were written on the sole.
Yeah, okay, that's more challenging though.
Because I always thought, yes, I love that. If you just read the instructions, you've done it.
I'm waiting for the other shoe to drop.
That's right, exactly.
Ah, yes, very good.
Yes, should have known that Phil would find the soulless pun.
It's my Achilles heel.
Oh my! I think we should be walking on.
Yes.
So is your book actually finished now?
So it's available from the publishers, and that's in the e-format. They're 10 chapters worth. I finished the writing ages ago, possibly nearly a year ago, and I've been fiddling around with the diagrams. It's being printed as we speak, so it's on pre-order on Amazon, and it sounds like the actual paper copies of the book about coding your way out of a paper bag will be available at the end of this month, so quite soon.
And you can pre-order those now, can you?
Yes. Just put my name in Amazon, you'll find it. Other booksellers are available, of course.
We'll put a link in the show notes again.
Yeah, Kate can do. So that I put the link earlier for the ebook, and shortly it'll be showing the paper book there as well. So
will you be at ACCU signing copies if people bring
I will
their copies?
be at ACCU. I shall be talking with Chris Simons about some evolutionary programming. We're going to do the traditional code your way out of a paper bag thing, FizzBuzz. That one gets mentioned loads. Do you know what genetic programming is?
I think I do. I read about this in a book that I was going to talk about a little bit, but why don't you tell us?
Well, what you can do is you can represent a programming language, and Andy can tell us more about this in a moment, by an abstract syntax tree. So if you've got a tree shape, you can do something similar to what you do with genetic algorithms, which is more of a sequence. You take half of one, half of another, and mash them up. Mutate things and come out with new lists. As soon as you've got a tree structure, you can do the same. So chop bits off from one tree and got loads of trees, loads of attempts to write, say, FizzBuzz, and combine them together, noodle around slightly, switch pluses to minuses and so on. As long as you've got a set of tests that you want your genetic program to pass, you can leave it to it, and it will eventually write the code for you. So AI can make programmers completely redundant as well. So watch out, world. So it's an extension of genetic algorithms, but tree structures. So you can automatically generate code. You won't want to look at the code that's been automatically generated afterwards, but I mean, what can you say?
So I had read about these and was intrigued by this so long ago that when I first saw generic programming, I misread it.
Yeah.
I thought it was kind of interesting. It's like, why are these templates so important to do genetic programming? And then I read it again. It's not genetic programming. Oh, this is something different. And but I noticed that among the buzzwords on the front of your page is AI, and I've been somewhat intrigued on this because when I was in high school, I think I bought this little tiny booklet, and it was called Modern AI Programming or something like that, Artificial Intelligence Programming, and it was kind of an overview. I mean, it wasn't like a deep, here's how to write all this code, but it talked about AI and the different branches of AI, and I was kind of intrigued about that, and then didn't think too much about AI for many years. And when I looked at it again, looked into what AI was, things that were identified in the book as AI were no longer considered AI. And so, for example, expert systems. Well, expert systems was in this book as artificial intelligence. But today, no, an expert system is essentially a database, right? We just run a database. So it's not really artificial intelligence. But what it drove home to me is that the term AI what this means is things we can't quite do yet. Because as soon as we figure out how to do them, that's not AI anymore. And I really think that's what AI means to me. I know it's not what it's supposed to mean, but I really believe that once we figure out how to do whatever it is, like expert systems, and once we feel like we're comfortable with that, and it's no longer, black magic, well, then we say, oh, that's not really artificial intelligence. I think to a certain extent, we don't really know what intelligence is. We don't know how it works. And I think we never will, because the more we approximate it, the more we say, well, that's not really intelligence. That's just mechanics, right? That's just a mechanical.
That's really interesting. I guess that's partly why you end up with the Turing test, isn't it? I mean, all this dates right back to when we started making computers in the first place, which I personally believe Turing did because he wanted to play chess with someone. So loads of the AI machine learning dates back to building games that you can play with computers. But yeah, so Turing avoided answering the question of what's actually intelligence and said, well, if it can pass the Turing test, if you can't tell, that's good enough. Yeah, so my undergraduate degree was in mathematics and philosophy, and people say about philosophy that you ask broad questions there and try stuff out, and as soon as you start getting some knowledge and some skill or some understanding or science around what you're doing, like sociology or psychology, then that subject area gets an actual name. So that's just like you described for this whole AI thing. And then, yes, an expert system is what the experts have said. And then you just find the closest match in your database. That's got a name. And then we get branches like deep learning that are doing some specific things. I think anything that's got the word learning in, you should be suspicious of.
So are you saying then that the idea was that there was a time when psychology was really philosophy, but once we get enough of an understanding about psychology, it's no longer philosophy. Yeah. It's now its own. So it's not so much that it has its own name, it's that we no longer consider it philosophy anymore.
Yeah,
because now it's a science.
There's an analogy there. I mean, the beginnings of various branches of science were called natural philosophy, weren't they? Right. So yeah, this thing happens. Words change, and that's telling you something. Not sure what, but something.
I think we can extend what you're saying, John, in both directions. The tree searching in order to play chess was considered AI, right?
Mm.
And then recently, and then that stopped being considered it. And then recently, something like speech recognition using neural networks, that was probably called AI. It's probably not called AI anymore. So I think the pattern fits.
Well, just neural networks. Yes, that was the early AI. And I think it actually is true. At first it's all magical, and so we call it artificial intelligence. And then when we begin to understand, we say, well, that's not intelligence. That's just mechanics, and so it's not intelligence anymore. And I think this, I don't know what the upshot of that is, except be a little wary of the buzzwords and don't expect. I think right now. So I worked at a large company, and I'm not gonna mention it. Anybody who knows who I am can figure out what the company was. But they actually, our part of the company was tasked to use machine learning for part of what we did. And this was a very, very high level thing, because it was really important that the CEO be able to say, and we are now using machine learning to do this. And that was the real driver, right? It wasn't that we thought it was going to improve things, although it actually did. It improved the ability of the software to do what we were trying to do. But the real thing was we wanted quantitative measures and say, we are now using machine learning for X number or X percent of this work that we're doing. And do you feel it's overhyped? What do you think?
A lot of people say we're doing machine learning rather than using. They use strange phrases. And actually, when you get down to it, a lot of them aren't doing anything that's technically machine learning. And some of the things you can apply machine learning to, just looking at things sideways. Interestingly, if you start looking at your code base and start looking for some of the hotspots and what's going wrong in there, do some kind of a data analysis, you can find all kinds of things out that wasn't what you were supposed to be looking at in the first place. Yeah, be skeptical about anything. It's definitely a buzzword at the moment. And I'm definitely spotting it changing from being machine learning to starting to be called AI again. I think that fits in with the self-driving cars and robots, though. This wangs around between hardware and software if you look at the history of it over the last 60, 70 years. Yes, be sceptical. But don't be completely downlit, because it can be really cool, really interesting, and give you ways of analysing data or trying to solve a problem where you couldn't possibly try everything. You might find something that works. So sceptical.
All right. So many of our listeners are going to be, programmers. They understand code very, very well, but they don't know what this buzzword machine learning is. So what is machine learning? I mean, explain it to somebody who's technical, but isn't familiar with this term of art. What does it mean?
If you read any of the literature, people are saying machine learning is when machines learn from data. So my headline thing is, no, it isn't. The machines don't learn anything.
Okay.
They don't it doesn't always involve data. Now, it can involve data, and you might learn something. In the same way, if you did some statistical analysis or tried graphing things in different ways, you might go, oh, there's a hotspot happening here, or whenever someone commits code on a Friday afternoon, they always break the build, or you might spot some kind of pattern. It might be from data. It might not. There's things, if you're trying to plot an itinerary for visiting loads of cities, so a classic thing is a travelling salesperson problem, where a salesperson tries to go round each city once and end up where they started. You can't try everything, but you can use some algorithms. As we were chatting before we went live on air, Andy was mentioning some things get called AI and sometimes they just get called algorithms. There's some known algorithms that to get you a pretty good itinerary which will minimise or get close to minimal the amount of time you're spending travelling around.
Doesn't mean it's a heuristic and not an algorithm?
Yeah. So a lot of the machine learning stuff will use heuristics, or you can give it some heuristics and then it can weight them. So you can say, well, I think this might work, or this, and then just leave it chugging and it'll tune them and go, actually, that heuristic was rubbish, but this one seems to be working better. But then you need to define what you mean by better. So this is often about coming out with some tests in some way, shape or form to see whether it's doing what you want or not. So problem solving or investigation, trying to find anomalies or things that work or things that don't work, or algorithms. Yep, that's a good word for it. Well done, Andy.
Or tuning, parameter tuning. Right?
Well, the model I had in my head of what machine learning actually is an algorithm or a set of algorithms that's actually designed by the program based on curve fitting the data, if you like. Although that's maybe an oversimplistic view, but that's really the model. It's the algorithm that's been produced by the program rather than the algorithm's been produced by the programmer and then is just used, which is sort of algorithms we normally work with.
I mean, I guess that kind of works for some aspects. I think it's quite a vague term that doesn't mean one thing. But if you've got a algorithmic trader who was trying to design a trading system, that would certainly look at these parameters or try and choose when to buy or sell. And you could just leave it chugging. But you need a kill switch on that, and you probably do, and all these things need some kind of human in the loop and a way to turn off the AI.
You can say that about traders as well.
Yeah. So I think what you're kind of hinting at there is that what may happen is that these give us insights, but not necessarily solutions. I think that's the difference between an algorithm and a heuristic, right? An algorithm is guaranteed to give you the right answer. That's what you do these steps, you'll get the right answer. That's what it is. A heuristic is something that says, you do these steps, you may get a good answer, or often you'll get the best answer, or something like that. But it is, in fact, not guaranteed. It's not an algorithm. It's not guaranteed to give you the answer. And instead, it's something that's likely to give you something close to the answer, or something that's likely to give you something close to optimal, or something like that.
Yeah, definitely anything that includes ways of you managing to explore and investigate and look for patterns and try and come out of solutions to any kind of problem. Yeah.
You mentioned trading systems a moment ago, and I know you do have some experience with that. I don't know if you have experience with trading systems using machine learning algorithms, but that's really an interesting area, because a lot of times that we're talking about machine learning, we're talking about the computer doing something that we as humans would find actually quite easy, like, typically classifying photos and things like that, or identifying objects in the bagging area in a shop. And it seems to do sort of okay, but actually quite poorly for that compared to our own experience. When you come to using these algorithms in trading systems, you're often using them to do things that even a trader wouldn't necessarily be able to do, and sometimes doing better than the trader could do. How do we know when it's working or not? We talked about testability earlier, and particularly when it comes to large amounts of money on the line. Obviously, there's got to be a lot of sort of fail-safes around that as well. Is that something you know anything more about?
Excuse me. Only bits. I mean, I've seen some algo trading going on, and there you end up in a place with difficult to draw a line between machine learning and statistics, and as you said, curve fitting. Usually there will be some kind of kill switch in there, so you can turn things off. Sometimes you let things run for a bit, but then you need another way of spotting the market conditions have changed. And the classic high-level thing is there's a trend following. So it looks like everything's going up, so you just follow the trend. And then there are other things that do seasonal things. So you kind of basically a sine wave, so you need to work out when you've hit the top and you're going down again. But then, of course, you end up with Fourier transforms on things. But all of that seems a bit more like curve fitting. And I think in most cases you will have that kill switch so you can stop things when it goes wrong. Though I'm sure we could all think of some examples where if something's doing some high frequency trading, even if it takes you a few minutes to switch off the button or an hour, you might nearly wipe out an entire company. But that isn't the machine learning fault. You can do as badly with statistics if you want to.
Yeah. It's more the that disconnect between understanding what the algorithm is actually doing and being able to reason about whether it's doing the right thing or not, because it may actually be doing something unpredictable, and realizing that it's doing the right thing, you just hadn't caught up with it yet.
Yeah. If you look at some branches of machine learning, like the deep learning, it's very hard to try and put into words what on earth you've actually built inside the model, because there's just so many parameters. Some other branches, like decision tree induction, try and actually spell out the model and what they're doing in words, and there are a variety of algorithms or techniques for trying to come out of a summary of what the deep learning's actually up to. But yeah, there's so many calculations going on inside this essentially black box. You don't know what it's doing. Yes, difficult.
Similarly, it reminds me of that story that we saw last year, and I think there might be more than one of these. And obviously, you can't really take these in isolation. But with self-driving cars, I think it was a Tesla, and there was a dash cam running, and the car started slowing down autonomously and changed lanes, I think. The driver didn't know why. And then it's only some seconds later that some incident occurred up front, and they would have been involved in the collision if they hadn't taken that action at that time. Driver couldn't see it. You watching it can't see it unless you really know what you're looking for. But the AI, if we want to call it that, spotted it and took the right action.
Right.
And in that case, being able to rely on that can save lives. And yet we don't know what it's doing.
Yeah.
It's really scary.
Yeah. Yes.
Well, I think the thing with cars is, I think the potential to make something safer is high, because humans drive pretty well on the whole, but at the margins not very well. I think computers can do better, but I think what's going to happen, and there's going to be some very, very well-known and maybe tragic because it's a celebrity or something, there's going to be some accident, which if a human had been driving, the human could have avoided that particular accident.
Yeah.
And that's going to be what's going to be the popular downfall of AI driving. Because yes, you're going to find out, and insurance actuaries are going to be delighted at how much safer we are on the whole. But there's going to be some famous incident where, Lady Di or something like that is going to be in a car accident that a human could easily have said, "Oh, I see what's going on," and avoided it, whereas the computer was not able to figure out in time what it was looking at. And I think we want that kill switch because we think we're worried about the computer being out of control, particularly when we don't really know how it's getting to the solution it's getting to. I mean, this is the famous, I maybe everybody's heard of this, but in the very early days, the military wanted to figure out if they could have the computer tell them if there was a tank. So what they did was they took a whole bunch of pictures of a forest without tanks and a whole bunch of pictures of forest that had tanks in it, and they tried to see if the computer, and some of the pictures were used to train. And so they went in and said, this picture has a tank, this picture has a tank, this picture doesn't. And then they ran a whole bunch of pictures that they'd never seen in the computer before, and it was amazingly accurate at determining whether or not the tank was there. And so then they reverse engineered and said, what did it figure out? And it said, it figured out that depending on what color the sky was, because all the tank pictures were taken on the same day and all the non-tank pictures were taken on the same day. Yeah. So it just figured out what color the sky was, and then there was a tank there. I think that's the scary part about when we don't know why it's doing what it's doing. It may be doing something that a human would have said, no, that's ridiculous.
If I start seeing tank pictures come up in my catchpers, now I know why.
Yeah, now moved on to more complicated things like cats or dogs. I mean, I've heard some recent tales of the computer vision, and they tracked it down to one of the cameras that got a little nick in the lens. So the AI was spotting that, and that was a dog, because that was a much simpler thing to hang on to. I did a keynote at Q a few years ago about AI, actual intelligence. And whilst I was preparing that, I was thinking, I guess if you have a kid, my first career was as a school teacher. If you teach someone something, they sometimes get better at it than you. And you can't always understand how they have worked out a quick way to do mental arithmetic, or maybe if you've got a mentor that you train to program a computer, they get better than you are. Is it okay if you don't understand what they're up to, even though you've kind of created or encouraged this? Oh, yeah, difficult question. Sometimes you want the kill switch. Sometimes that might not be better. This is difficult.
And so AI and machine learning also contain psychology.
Yeah, it crops up everywhere, doesn't it? And maths, yeah.
Let's talk a little bit about code, because I'm hearing things like, is it Amazon or maybe Google or Microsoft, that their cloud platforms now allow you to do machine learning. You just plug in and they do the hard work for you, and you just plug in and you could leverage their cloud-based machine learning. What exactly is it? I mean, what is it they're doing there that I can plug into?
I've not followed the details. I did see an announcement from AWS that you could just
maybe that's what I'm thinking.
Give it all your data, and then click some flips and switches, and it'll try and fit curves to it or help you find patterns in there. To be honest, my main focus, and particularly in my book, was just trying to do things from hand, writing code yourself so you understood how they worked. But loads of people are selling machine learning solutions. They've got code that instantly does things for you. Loads of these are based around neural networks, which I always describe as regression on steroids. So send some numbers in, and it'll do some multiplying and adding up, and send some numbers out. And that might be like your tanks example earlier. Tank, not a tank. Tank, not a tank. Give it all your pixels, and it'll tell you where the tanks are, and possibly based on what colour the sky is. I've not investigated them properly. I think a lot of them are to do with the neural networks and the curve fitting, and they've probably got some graphing things. So what gets called unsupervised learning. So you don't have a training set and say tank, not a tank. You just give it all your pictures, and then it says these are similar, these are similar, and there's another group here that's similar. So it shows you some clusters or groups of things. Well, I've not played with these, but yeah, Amazon has got loads. Amazon's got a finger in every pie going. Obviously, there are loads and loads of different Python libraries that you just chuck your data in and off you go. But yeah, they're find patterns or spot tanks or cats or dogs or whatever you want.
So when I was at Amazon, what I worked on was the search engine.
Okay.
Now, I didn't work on ranking. That was a different part of our organization. We worked on retrieval. And basically, the other organization figured out how to rank. And that organization was doing heavy machine learning kind of experimentation stuff. And essentially, the way they were doing it is they, of course, I mean, the problem with ranking is that it's always subjective. I mean, you can say, well, you know, oh, I'm looking up this term, and here's a web page that's all about this term, and here's another web page that just mentions it. And you objectively say, well, this should be ranked above this.
Yeah.
But when it comes down to the details, it's always subjective. So the only thing they can do is, and of course, I assume they used Mechanical Turk or something like that. Mechanical Turk is Amazon's tool where you actually hire people to do something that humans have to do, but you make it like a computer program, and you give them the same data and say, make the decision. So what it was doing is it was saying, they would test this by saying, if we gave you these results, how would you rank them on a search like this? And so they would compare, and then, so then the machine learning, what it did was it would, there's a lot of things that you could use as input to searching. In other words, Amazon, of course, is searching for documents of things to sell, right? These are all products, essentially. It's not the generic web search kind of problem. It's searching on documents. So, so what do we know about this? Well, we know what the product name is. We know what the manufacturer name is. We know something appears in the description. It's possible the search term is in the description multiple times. So there's all the, and how early in the description does that search term appear? There's all these things that might impact how things could be ranked. And essentially what they're, at least this is how it was explained to me by the people who were doing this is, they were essentially coming up with coefficients that you would apply to all these things. In other words, if it turns out that from the answer given to you by the humans looking at it and say, yes, this is a better ranking than this, then you go back and you say, well, here was the coefficient that would have generated that, and that it rates heavily on how often the term appears in the description, or does it appear in the product name or whatever. And so it was essentially just a best fit matrix. And what the machine learning was doing was just coming up with a bunch of coefficients for the, you know, you throw as many possible determinants at it as you can. How many properties of this document are possibly related to the search? And then you figure out how to weight each one to give you the best overall answer.
That's a really good way of describing it. I mean, and Andy threw in the word parameters earlier on, so that fits in with this. And I glibly said it was just multiplying and adding up. The multiplying is those coefficients, and then you add them up afterwards and go, well, this one comes first, this is second. And some of the better or harder machine learning things are more dynamic. So instead of giving them one set of tank pictures and no tank pictures, and it learns, and that's your algorithm, you want to do something dynamically so as it can change and evolve. And then this is why so many companies ask you for feedback on things, so it can then feed that in and keep changing things over time. But yeah, the multiplying is just weighting the inputs, and then we add things up afterwards and come out of a ranking or a number. That's what most of it's down to. So yes, some simple sums, but over big numbers. Of course, this means you've got to decide which descriptors to send in, whether it's these words, how often these words happen, and that can bias things. And then we're going to end up into a whole other long discussion if we start talking about bias. But yes, may not go down that wormhole today.
So I have a question, Fran. In your book, you look at a number of different types of machine learning.
Yep.
Which one is the best one?
Oh, it depends what mood I'm in. I've got a soft spot for.
Is there an algorithm for it?
Yeah, well, I'm not sure. I should probably do this, and I'd probably be able to spot what mood I'm in. I like genetic algorithms because I think I understand what's going on there, and that gives you a way to. Well, it's kind of like just randomly trying stuff out, but a bit more guided. So I can see how they're working, and I can see how to apply them to loads of different things. I also, my PhD, I looked into ways to induce decision trees. And unlike some of the deep learning stuff, that you end up with a readable set of rules afterwards, or a tree that says, is it this or that? So then you can see what it's suggesting to you. And it's again gives you a way of displaying your data or the problem you're looking at that lets you go away and think about it. So I like the kind of algorithms that just give me a different perspective on something I'm thinking about, and they give me things to think about. So
shouldn't we call that machine teaching?
Oh, that's a good one. Let's coin that. Right, we're having that one. Yeah, I mean, I like the word exploring, but yeah, teaching, yes. The machines never learn anything. They just have numbers to multiply things by. We have the insights.
But they might give you insights.
Yes,
right?
exactly.
I mean, that's the thing, whether it's the decision tree they tell you about, or perhaps you throw a whole bunch of data at it and just let it crank out the coefficients. And then you're surprised when you look at this and you say, we didn't ever think that this input would be so deterministic of the right answer.
Who knew
and so it gives you an insight.
had to be blue for there to be tanks to be there. Yes, exactly.
Right. Or in the case of, and I definitely can see this in the case of genetic algorithms, when you look at the answer that the computer comes up with, it suddenly gives you an insight and say, oh, hadn't thought about that approach, but having seen that approach, perhaps I can write code better than the computer. You know, the computer gave away the secret. Now I figured out how to optimize it by applying human intelligence to an answer that seems to be, I can find the local minimum, having been pointed at what's likely to be a successful solution.
I mean, some of this stuff isn't always numeric. Have you seen the Wikipedia picture on genetic algorithms page? I'll dump this in the chat. So sometimes you can make genetic algorithms design circuit boards and other things with shape, which then crosses over into how the genetic programming's worked. So I've just trying to put a picture into the chat. An AI, a genetic algorithm basically designed this antenna because that was optimal for sending and receiving signals. No human would have come out of anything in that shape.
Wasn't on my radar.
What is it? I mean, madness. So some of this is spatial things as well as number crunching. Crazy, interesting, amazing.
But the real question is, I guess not the real question, but an interesting question to me is, would someone whose job it is to design antennas, would they look at that and understand why that's successful? They might not have come up with it themselves, but having looked at it, you know, the computer saying this is the best solution, do people who design antennas look at that and say, oh, now I see why? And having seen why, could they take it to the next step and say, I think we could do even better than this, now that we figured out that there's something that we hadn't thought about the way the antenna is feeding off of itself or something.
I need to look up more on that. There's another story I've heard of, and I'm not going to be able to find any links to put in the Slack channel here, but an AI designed a circuit board. And
that was Adrian Thompson.
Right, part of the circuit board wasn't connected. The electrical engineers looked at it and went, what on earth's this for? That's ridiculous. Took it out, stopped working. It was inducing current. And they hadn't thought of that. And it was actually very effective. But that's not something a trained engineer would normally get away with. It makes you think. So whether it's useful, easy to manufacture or not, or sensible, is a different question. But interesting. It definitely comes out of lateral approaches. Because you've let it explore anything that's possible. Careful what you wish for. That
was a very cool set of stuff. That was done at Sussex Uni where I was.
Right.
By Adrian Thompson and others. And it's an interesting example of some of the things we're talking about because, the genetic algorithm did find a sort of novel solution that you would never design, and it did work, but it was also very unstable. it only worked in the very specific circumstances it was created in. And when they did more work on making circuits that would work when they were a little bit hotter and a little bit colder as well, and things like that, they got much more conventional circuits out of the algorithm. So it was a very interesting example of sometimes this kind of search can lead you to solutions that are essentially useless but are really cool.
Because they're brittle. It's useless because they're brittle.
Useless if they've been evolved or machine learned under circumstances that don't apply more generally. Or if they happen
be
to find
examples of overfitting. We were talking about curve fitting earlier.
Works on my machine.
Yeah.
Well, or also, I mean, one of the things that I have kind of been exposed to a little bit is these competitive coding situations where people are given a short period of time to come up with a solution. Here's the input. You need to do this. And I'm on the one hand, it's kind of interesting. If somebody is good at that, they probably have good potential to be a programmer. But on the other hand, they're not learning the kind of skills you want them to learn because they're not learning to write code that is likely to do the kind of error checking you want. It's probably not portable. It's probably, it's just way brittle because they're trying to solve a very, very specific situation. And that's not what we normally want. We want code that solves a particular situation, but is in the ideal, reusable and generic and understandable, not something as brittle as, I can make, even though the assumption is, or the statement is that this is true, I'm going to make additional assumptions like, well, there won't probably be more than this amount of data because they wouldn't want to test it with that amount of data. So you can make additional assumptions that aren't in general true, but they work for your situation. And then you write code that's virtually unreadable, but that's fine because you understood it when you wrote it, and that's all that was matter because it worked then. And so I think that's what you were trying to say, Andy, is that you can have the computer essentially doing the same thing. It's like, oh, the computer is writing a solution that is not in general useful, but does work in this particular situation because the constraints are so strong.
So when you're trying to control that kind of algorithm to produce useful stuff, you spend your entire time with it tricking you, and then you figuring out a way to prevent it tricking you, and then it just cycles round and round.
It's kind of like measuring code because the compiler keeps optimizing away your measurements, right? How long does it take to do this loop? And the compiler looks at it and says, well, you're not taking the results of the loop, so it doesn't take any time at all. Yeah, interesting. an interesting problem. Yeah.
So you want it genetic, generative, and generic.
Something like that.
We talked about curve fitting quite a lot.
Genius.
I mentioned overfitting a moment ago. Is it worth explaining what we mean by that for those that are not familiar?
It's kind of like when it works on your machine and then doesn't work anywhere else. So, back to the tank picture example earlier on. Okay, so you start with some training data and it gets perfect 100% accurate on that. Great. And then you try it on some data it's not seen before and it all goes horribly wrong. So if you're not really careful, if you give the simplest algorithm that takes some data, so lots of different X values, and tries to get a Y value, you might as well write a lookup table. Then you're going to be pretty much 100% accurate, unless you've got two identical inputs with a different output. 100% accurate, fine. If it then sees data it's not seen before, it's not going to be anywhere near as accurate. So the closer you get to that lookup table, where you haven't actually tried to generalize, the more you've overfitted or just memorized what you started with. So I think overfitting and memorizing on a training set and not applying generally is the best way to describe it.
Right, so that's overfitting. But what about curve fitting in general?
What about it?
What is it?
So, well, it's an insult, really, along with terms like data dredging instead of data science. If you've got loads and loads of points, you can try and draw the line of best fit through them. If you've got loads of heights and weights, there might be an approximate shape in there that kind of fits. If you're looking at velocity and acceleration, you might get a line that tends to fit through the observed results. If you're looking at some other things, like C++ programmers, number of years experience, and how many unit tests they've ever written, you might not get one line. You might actually end up with 2 lines or trends going on in there. So sometimes if you try and fit one line for a set of points, obviously that works for X and Y axis. You can do a line. If you've got more descriptors or inputs, you've got more of a surface. So curve fitting is just a general way of describing this. You're trying to come out of an equation that predicts one of the other numbers from the inputs, which you could draw as a line in 2 dimensions. So you are trying to do that generalizing where you're not overfitting and not just having a lookup table, but actually working out a function. Or as I said earlier, some multiplying and adding up. You can get all swanky and put some sine or cosine functions in as well, but they're just multiplying and adding up too. But it's trying to come out of an equation that fits your data, but that's why trees are really good, because then you could do if and else and have different equations depending on some of the descriptors. But you could do this or else with some multiplying and adding up. I didn't think that one through, did I?
Yeah, so one of the sort of steps forward that the field made was from having to know what type of curve you were going to fit and then just doing maths to fit it, through to things like neural networks with backpropagation, where to some extent that lets you not say what kind of curve it's going to be before it gets produced.
Yeah, make the computer decide for you. Yes.
Kind of. Although actually, I mean, it's still constrained. It's just it's the different set of constraints that give you more flexibility potentially.
So we've got a few minutes left. Have we got time to talk about how C++ comes into this?
Yes, not long. Well, I said earlier on, I'm seeing people say machine learning is when machines learn from data, which is not. Partly, but that's not the whole story, and that's not even true. People are also tending to say Python is the language for machine learning, but that's because there's so many different frameworks in Python. And I love Python, and there's some Python in my book, but there's also some C++ in my book. And if you want to do some serious number crunching, you might want to consider doing it in C++. So, yeah, and actually there are some C++ frameworks out there. Write your own. Enjoy. You can do some machine learning in C++ if you want. Any language of your choice. But yeah, particularly for some of the numerical grunt work, that's, yeah, go for it. It's important.
Are these libraries designed so that the interface to ask the questions is in Python, but the cranking of the numbers is in C++? Is that how they're doing it?
So some of the things in Python are using some highly optimized things in NumPy and some similar numerical libraries. So they are using some C++ in the background. I'm not up to speed with where all the gory details of the internals are, but yeah, a lot of the heavy lifting's happening in the background in C++.
So if I read the book, am I going to be learning about the theory of machine learning, or am I actually going to have pointers to specific libraries? Or
well, I've steered completely clear from libraries because they move so fast. You will only get a small handful of things, some stuff about genetic algorithms, some stuff about cellular automaton, how to build a decision tree, what a Monte Carlo simulation is, and some swarm algorithms but they're doing multiplying and adding up, to be honest. I've steered well clear of any of the neural networks or deep learning because the maths was too hard to explain simply. You'll learn how to code your way out of a paper bag using a variety of techniques that are totally inappropriate and over-engineered for it. You'll learn what some of the words mean. It's not written like a textbook. If you want to learn how to do this and apply it at work, you probably want somewhere else. If you want to just a gentle background read with a few ideas in to get your inspiration going and understand how some of the things might be working under the hood, then yeah, this is the book for you. If you want in-depth on different frameworks or deep details about deep learning, then you need a big heavy textbook instead.
Yeah, this is the way I understand stuff is to try and write it myself, right? So
yes.
What we're getting here.
Yeah, sometimes, I mean, I feel the same way. Rather than, I mean, I can understand what's going on in a game by writing a simple game. I'm not writing a really, but I can mentally extrapolate that out. I feel like I've done this part, and now I realize, if I had a lot of time, I could really take that to the next level. But I understand, I feel the same way about. I mean, when I worked at Amazon, I worked on the search engine. I've never written a complete search engine, except I have, because I've written a toy search engine, just to see, how it all goes. And then you start to understand a little bit about what's going on, even though you understand where the optimizations would be and what you could do to make it, dramatically more complicated, but you could get better at it. And I think that's how I learned to understand things is do the toy one and then mentally extrapolate out and see where you would go if you had lots more time and effort to put into it.
That's why Andy's been writing his own programming language, really, isn't it? See how this works.
It is, yeah.
Would like to dig into that, but I think we're going to have to wrap it up. If I could say it's in the bag.
Oh, well done.
Don't encourage him. We'll just have to paper over that.
Yeah, okay.
Just to ask, are you speaking at any events coming up?
Well, the first event I'm going to be speaking at this year is in Folkestone in about 3 weeks' time, called C++ on C. I shall be looking at some C++ code there to diffuse your way out of a paper bag. I've got some other talks coming up. I'm talking at NordevCon about genetic algorithms and doing a talk with Kevlin about how to recover from feeling a bit depressed, and so more kind of coping with life talk. And yeah, as I mentioned, also going to be at ACU doing a workshop about evolutionary programming and a 90-minute session where hopefully we can get the computer to do FizzBuzz for us. So yes, loads coming up.
Excellent. Because the FizzBuzz problem is one that we're yet to crack, I think.
We've tried so often. And
we've tried so often.
Stupid enough. This requires a completely over-engineered one, and this is it.
Well, congratulations to your C++ on C, because I heard that there were lots of submissions to that.
Yeah.
I'm sure it was very competitive, so you should be pleased at getting on that one.
Thank you.
What about you, Andy? Are you speaking at ACCU this year or anything else, anywhere else?
Yeah, I got an ACCU talk on Kotlin real-world examples of where Kotlin improved our real-world Java code, or could improve, I should say. Also, doing a session with CB on Git, where I'll be asking CB lots of difficult questions about how Git really works. Hopefully we'll find out.
Excellent.
I'm glad they're directed at CB and not at me.
or me, yeah.
All right, so are we ready to wish people safe coding?
I think so. So safe coding, everyone.
Safe coding.
Safe coding.
Safe coding.